Hello everyone, today we're going to work on exponent rules, and specifically we're going to work on going back and forth between exponential and radical form. So when we're doing this, it is key that you understand that there are some exponent rules out there. You've learned these already. Just a reminder, you have the one where you're multiplying, the one where you're dividing, the one where you have the powers that are nested, the one where you get rid of a negative exponent, the one where you get rid of your zero exponent, and I know these are shortened versions, there's a little more to them. And the new one here I have in pink is just kind of fun. What I would want you to see in this one is if you have something that has a base of A, that has an index of N, and it has a certain power, we can do one of two things. We could rewrite that as same base. Look how this N, the index, goes on the denominator of a fraction, and the power is the numerator. So that's kind of a fun little thing. And then we can also, let's get rid of some of these markings here because they're a little bit overbearing. Let's take a look at what else you can do with this. You can rewrite this. A to the nth root is still A to the nth root, but you could physically remove this M and you can put it on the outside. And there's going to be some reasons why we want to do that. We'll probably want to do that when we deal with anything that's negative. That'll give us the chance to move some things around. All right. Now, before we go any further, here are the examples we're going to do in this video. We're going to start at the top and work with some basic ones, and we're going to get crazy down here at the bottom. Feel free to fast forward around to try to find the portion of the video that you need. If you want to watch the whole thing, here we go. All right, so we're going to start with the top row. And in each one of these, my objective going into it is that I'll turn something that is exponential into something that's radical. So for example, and in doing so, I'm going to be simplifying. So I don't know what 64 to the 1/3 power is, but using that rule from the previous one, I'm going to take my bottom number, my denominator, and that becomes my index. I'm going to take the top number, and that's going to be my power, and the base of 64 stays 64. Now, we know 64 to the first power, we don't really need that, so I'll take the 1 out. And the cubic root of 64 equals 4, so look, done. So 64 to the 1/3 power is 4, and that's actually kind of a neat way to work back and forth between radical and exponential form, and then how to simplify in both cases. Here comes the second one. Now let's deal with the one with 7s. We can do this two different ways. One of them would be to turn each of these, right, turn this into our radical, and do it again over here. We know these are square roots. We know we don't normally have to write the 2, but just for the sake of the example, I'm going to write them in. And then we could do the, let's see, we have the same radical, so we can do 7 times 7 is 49, and then we can we can take the square root of 49 and get 7. That would be nice and simple. But it is worth noting that there's a way to attack this problem. The other way to attack this problem is to recognize that we have a rule that says if you have the same base, you can add the exponents, and 7 to the 1/2 power times 7 to the 1/2 power ends up being 7 to the first power, which is the same thing. So two different strategies. One of them applies the rule and one of them does it slightly differently. We both get the same answer. Things get a little bit more interesting when our bases are not the same, right? We happen to have the same exponent. That's kind of fun looking. But the fact that the 5 and the 125 aren't the same stops me from really applying any of those exponent rules. But let's not stop too soon. So we're going to go ahead and use the same pattern that we've seen a couple times now. We're going to make that the index, and we're going to make this the index. And now that we've done that, what we can see is that we're allowed to, because we have the same index, we're allowed to multiply these radicands together. Now I've done this in advance, so we know that this is going to become the 4th root of 5 times 125, which is 625. And then let's simplify. Now 625 is the same as 25 times 25, which is the same as 5 times 5, and again. So what I could do is I could rewrite this problem as the 4th root of 5 to the 4th power. And only for the students that are usually in my room, at this point I can do some slashing out. We'll go back to blue, and the correct answer here is the principal is 5. Right? Nice and simple. So that is, again, quite a bit simpler, and I can use I don't even need a calculator for that. All right, next round, we're going to deal with stuff that involves some variables. This guy here on the left, there's not really too much to it. All I'm going to do is apply that same rule again. Let's make that our index. Let's make this our exponent. And let's make our base 7. Now, I can't really do anything with this. I guess all I can really do is I'll show you that you can write it twice. One thing that you could do is keep the index the same, keep the base the same, and you can move the 3 onto the outside. So these are both just the radical equivalent of what we started with. So you could use the one that's exponential on top or the one that is radical in the circle, and the radical one can be written 2 different ways, whatever is easiest or whatever you need. Let's go to the middle one. This one looks a little ugly. Y to the negative 3/5 power. All right, I'm not going to be bothered by that. I'm going to turn this into a fraction. And once it's a fraction, I can kind of do the same routine, right? I'm going to grab my index. I'm going to grab my exponent. Now I'm going to grab the negative with the exponent, and I'm going to put negative 7 here, and I'm going to put my base inside. Now, using that technique that we learned before, I'm going to go ahead and, I don't like this negative in here. I really don't want it in here because it's going to cause me problems. I could use it, but I'd rather move it outside and put this whole thing in parentheses. Now, because I need to do a little bit more with this, I'm going to clean this up. Normally, we wouldn't have a 2 on the square root, so let's get rid of that. And I also know there's a rule that if I have a negative exponent, I can flip this thing over and make this a positive exponent. That's one of the exponent rules at the top of this video. All right, so now let's rationalize this. To rationalize this, I'm going to need one more y in order to have an even number. And the even number with the square root is going to work out real nice for us. So I have square root of y to the 7th power times one more square root of y. So now I have the square root of y to the 8th power. All right, I can live with that. And I have the square root of y on the top. And here we go. On the bottom, I'm going to have y to the 4th and square root of y, and we're done. Oops, not 4. The square root of y. All right, simple enough. If you're not sure on the step, by the way, this step that went from the square root of y to the 8th power, think of it like this. The square root of y, if I rewrote it, it would be y to the 1/2 power to the 8th power. So if you imagine, like, let's use pink here. If you imagine that I turn this guy into this, then I can multiply 8 times 1 divided by 2, and that's where I get y to the 4th from. So if you were not sure on where I did that or how I did it, that's how that worked. All right, let's keep going. This next one's going to be pretty similar. Let's grab blue again. This isn't really going to be a whole lot different than the one we just did, so you may want to fast forward. I'm going to have 16 to the negative 5/2. I'm going to rewrite this thing as the square root of 16 to the negative 5. And for many of the same reasons as before, I'm going to go ahead and move this out. I'll throw parentheses on here to keep us nice and fit. And on this one, I happen to know the square root of 16, so I'm not cheating it. I'm just simplifying as I go, and I'm going to use that rule about flipping this thing over. And if you're looking for exponential form, there it is. If your teacher wants you to multiply it out, well then 4 times 4 times 4 times 4 times 4 is 1,024, and either one of those two circled answers would be the same as 16 to the negative 2.5. All right, the moment you've all been waiting for, these last two whammies. The first one, now, couple things I see here. I see a radical in the denominator, so I'm already uncomfortable with that. I know I have to do something with that. But I also notice that I have radicals on the top and the bottom. They don't have the same index. They don't have the same radicand. Like, nothing's working for me here. But what I'm wondering is, if I just rewrite the things, will something kind of come about? So I remember that the index is the denominator of my fraction. So this is just x to the 3/4. I'm going to do the same thing. My index is my denominator, and the 2 is up here. And I think I just got lucky, and here's why I just got lucky. I can simplify the bottom 2/8 into x to the 1/4. And the rule for this, top of the video again, is subtract your exponents. Look what I have here. I'm hitting too many buttons. 3/4 and 1/4. Not only can I subtract those, but they even have common denominators for me. So this problem really became nice. So I have x to the 3/4 minus 1/4. That's 2/4, which is the same as x to the 1/2. So if exponential or radical, whichever one you want to write or whatever is required of you, there are your two answers. So look how much simpler that is, right? That is definitely a simplified version, whether you go with the top one, exponential, or the bottom one that is radical. And your teacher or your book or the test or quiz will usually tell you which one they want. For me, if I had to choose, I would usually pick this one. And then finally, perhaps even scarier looking, this one we're going to be on for a minute or two. So let's get going. When I see this problem, I notice the 2/3 on the outside, so I know I'm going to do something with that. I also see a bunch of stuff on the inside. If I could, I would simplify anything on the inside, but unfortunately, there's nothing to do there. There's nothing I can cancel, divide out, add or subtract, multiply, divide. There's nothing. So I'm just going to go ahead and start breaking this problem down, and I'm going to remind myself that each one of these things, the -8, the x, and then this x to the y, x times y, each one of these has a power above it. And at this point, hopefully you'll be comfortable with that. And the whole thing is to the 2/3 power. Now, we could probably even be a little bit fancier here with that negative in front. We're going to be careful with that. I'm going to group that together there because that's kind of how that should work. So here we go. I'm going to use that rule top of the video where if you have a power to a power, the rule was a to the m to the n equals a to the mn. That means I can multiply my powers. So I'm going to have -8, 1 times 2/3, x, 1 times 2/3, xy, 1/2 times 2/3. I'm going to write this one out. If you're watching the video this far, you probably want this. So watch what I'm going to get here. So now I have this broken up stuff. This sure doesn't look simpler. I do, however, observe something I can cancel out, so I like that. So there's finally the first piece of good news that I've gotten out of this. I have -8, and I have 2/3, and I have x to the 2/3, and I have xy to the 1/3 now. I'm going to redo that first step one more time. I'm going to remind myself that inside of here, the x and the y are to a certain power, and I'm going to go ahead and use that same power rule. So let's keep this. And the stuff here at the end, we're going to go have x to the pink one, right? The 1 times 1/3 is going to give me 1/3. And now I'm going to be on the y. The 1 times the 1/3, so that's 1/3 again. And this is starting to look like something. Look at this. Same base. I can add these exponents. And not only can I add the exponents, but they're already in common denominator form. So 2/3 plus 1/3 is just, heck, that's just 1. So this is just x. That's really nice. The y to the 1/3, I'm going to start kind of going around on this, y to the 1/3, and the number. I feel like I should be able to do something with this number. So I'm going to make this my index. I'm going to make my -8 my base, and I'm going to have this squared. Now for this one, I'm not going to move that 2 out of there because I kind of like that. I see that -8 squared is 64. And the cubic root of 64 is just 4. So that number actually simplifies quite a bit. Well, the x can come down. And the y, well, I guess it depends what format you want. If your teacher wants exponential form, you're done. If your teacher wants radical form, well, then you keep the x, you keep the y, and you just write the cubic root of y, and you're done either way. So that problem, I think that was the hardest one for sure. But definitely it was just a series of steps, just kind of keeping everything organized and kind of hoping that some things worked out for you. So I hope that helps you work on radical and exponential form.